Hi, I'm Bhavna. I'm 13 years old and I've got a puzzle that I bet you can solve in 3 minutes. Are you ready? Take a regular hexagon and join 3 of its alternating midpoints to form an equilateral triangle. The question now is, can you tell me how the area of the triangle compares to the area of the hexagon? In other words, what is the ratio of the area of the triangle to the area of the hexagon? Pause the video, give yourself 3 minutes and see if you can figure it out. Answer in 3, 2, 1. This is the kind of question kids like me solve on a weekly basis. In our Cuemath puzzle cards, it looks fairly simple but turns out to be enjoyably challenging. When you start to solve it, you could solve the problem using a lot of algebra, but none of that is necessary. I'm only in class 7 and so far I've been taught that the area of a rectangle is length into breadth and the area of a triangle is half base into height. I don't know how to calculate the area of a hexagon yet, but I know that it can be simplified into at least 6 smaller triangles. Even if you haven't been taught using the math box toys before, you can still see this for yourself at home using a normal pen and paper. Just join the opposite corners of a hexagon. But that doesn't completely solve my problem yet, because this big triangle in the center was made by joining alternating midpoints of the hexagon sides and not opposite corners. But that's not a huge problem. We can just draw out the midpoints and start joining them. That's starting to look interesting, but let's take it a little bit further. It looks like this hexagon can further be broken down into equilateral triangles, which we can prove are equal using side angle side congruency. The triangle and the hexagon both are made up of pieces of equal little triangles. Our big triangle looks like it's made up of 1, 2, 3, 4, 5, 6, 7, 8, 9 little triangles, and our hexagon looks like it's made up of 1, 2, 3, 23, 24 little triangles. Therefore, the ratio of the two areas can be written as 9 little triangles is to 24 little triangles, and since all of the little triangles are of equal area, we can divide both sides by little triangles and find that the ratio of the two areas is 9:24. But I like to leave it this way to remind myself of the logic that I used to get there. What's great about this method is that I didn't have to use any formula or concept that I didn't already know. All I did was simplify the problem to the point where it wasn't so scary anymore. And now I can move on to bigger and more challenging problems. Did you figure it out? How long did it take?